Good. Thank you. And a little bit like the previous talks, it's much a talk about trying to look for collaborators and partners going forward as it is about what we've been doing. I left CMU about a year ago to found this company, Platypus. We've been doing a lot of work over the years in multi-robotic systems, written a lot of papers, a fair bunch of them with Mellon, with real world in the title, and we've been doing it all in the lab. At the time, Mellon was in the lab as well. And we wanted to sort of take that out and really do the engineering and go out in the world and do what we were interested in. We'd worked with ground robots, air robots, but we actually went out, and our company is based around small boats that do collect information about water. Why did we do boats? Well, there's interesting technical reasons as a multi-robotics perspective that you go out and do boats. Water's fascinating. There's large areas, so lots of robots make sense. There's no obstacles or other pesky things that make the robotics hard. But you've got a fascinating 4D sensing problem. The water varies in gaps of 1 meter, 3 meters, 5 meters. It varies over tens of minutes, over hours. And so you've got this huge problem, and most of the time you can only sense something by actually touching it. So you've got to go everywhere and be everywhere and be there all the time. So all these things about sparse data collection and information maximization are really nice. So there's a really good motivation as a multi-robot person to have lots of robots and few users. There's also some lazy motivations. Boats are a heck of a lot easier than airplanes. They very rarely get stuck up trees. So over time, we've built a couple of robots. We have a few different models. These are about 4 feet long. To give you a ballpark, something like a $5,000 robot. So we've mostly succeeded in making them low cost, either a propeller boat or an airboat for water that's has got a lot of weeds in it. 2 hours training and a 16-year-old kid can be out there using this autonomously to collect a lot of data. And we did start this as a CMU project. We've still got CMU grad students and do a lot of research. We're a company that really likes doing research. So we're doing all the sorts of things that you would expect to do. Information maximization algorithms. How can we, given the data we've collected, where do we go next to collect more data using sort of techniques that we've heard of today. Things like path planning under currents. This is really interesting. Sometimes, very often, even in a completely open environment, the shortest, the quickest, or the most energy efficient path between 2 points is not a straight line. Often in a river, it's to go out to the shore and then go upstream that way. Doing things like long run efficiency. If we want to take a boat many kilometers down a stream, down a river, then you can take advantage of the currents and only use your engine to keep in the middle of the river, and we can go hundreds of times further on the same battery than we can by using the currents and by not using it. And back to work we've done a long time ago. Oops, this video was supposed to start a lot later. Doing team plans. So this is students over in Qatar earlier in this year with 25 robots in the water at once. Looks like you're not going to get to see it. Visual obstacle avoidance, all the sorts of things that you would normally do with robotics, and these are all fun. But, and I heard this is obligatory, you had to be doing some work in Africa to even come to this conference. So eventually we went down to, we took one of our products and went down to Africa. This was a really, it was the most fun trip I've ever been on, but we rather crudely disguised one of our boats as a crocodile and sent it out into these rivers full of hippopotamuses and crocodiles to go and measure water quality, dissolved oxygen profiles, things like that. And this was great because no one had ever actually been in this water before. There's up to 80 or 90 hippopotamuses in one pond we've been in, plus sometimes 5 or 10, 15-foot crocodiles that we ignored because they were sort of safe compared to the hippos. But it was really one of these things that these were Yale researchers. They worked out there all the time. And this was sort of the first indication to us that we actually had something that was useful. We did learn a fascinating amount about where autonomy is actually useful. A lot of the stuff we've been doing on autonomy, information maximization, when you got out there with people that had studied this water for 50 years, you turned off all that information maximization. They knew exactly where to go and get the right data. We do a lot of different things with autonomy and so on since then. This is a long video I can show you offline, but we eventually get chased by a hippo, but Fortunately, we got into deep water just before the hippo got the boat. So now with this product out at a company, and this is not a pitch session, just to sort of give you a flavor for what the robot does. This is a pond looking at vegetation, so we can go and map the vegetation density over a pond in sort of, a 5-acre pond in about an hour, get a map of that, or the bathymetry of the pond to know exactly the shape of it, which is useful for lake management, rainwater management, engineering studies. We can look at the raw sonar data and have a good idea what the bottom looks like. From a water quality perspective, we also spend a lot of time, collecting stuff you care about water. This is a dissolved oxygen map. We like that, the spatial density that we get with the robots. You can sort of see that there's a lot more oxygen on this side, which is protected by the sun, than there is over this side, which is in the sun all the time, heating up the water, dragging things out. From a data perspective, you then look at electrical conductivity, which is your sort of basic measure of the salinity of the water, and you can see how some of that correlated reasonably well with DO, some of it didn't, but there's also large spatial variation over this sort of maybe 150 yards by 300 yards, and there's really a lot of variation. It's also, if you ever need to go and take data for regulatory things and you're in trouble, get us to do it first and we'll tell you where to collect the data from. Now, as we did this and we started to get this out and we'd worked really hard on making a low-cost platform, wanted to do environmental stuff, we realized that we had a version of the bias problem that I heard a few times yesterday. And this is not at all to pick on our great customers here on the left-hand side, but we were getting it out to big companies that could take on the risk of bringing robots in, even at relatively low-cost robots, and do the expensive jobs they were doing. Universities and government agencies were getting our robots just like they get everybody else's robots. But some of the people that we wanted, the thousands and thousands of volunteers that go out every day and collect trash from water or do whatever environmental things, they couldn't get their hands on the robots because, $5,000 or $6,000 is still a big investment. And so our robots were ending up here when we really wanted them to end up on the other side of that picture. So what I sort of want to talk about and actually get maybe some involvement in is some of the things that we've been trying to do to rectify that bias. One thing we've been doing is STEM camps. They're fun camps. We combine robotics, environmental science, and data science, which is 3 pretty hot topics in technology nowadays. This part's taught by a CMU environmental science professor, CMU data science professor, and by the Platypus team. There's a Barcelona at the top there, and a local underprivileged school in Pittsburgh. We're running one on Lake Erie next month, where we give the kids a chance to learn how to use the robots, learn what the data means, learn what they should care about. But and this is nice, I think, but as with a lot of these sort of STEM camp activities that go on, at the end of the week, the kids sort of are stuck and they're sent home, and they don't get to take what they've learned and taken on. Now maybe it influences their studies and all those sorts of things, but they don't actually get to use it. So one of the concepts that we're working on is this idea of a citizen science environmental center. And the fact that I stole a picture of a library and relabeled it is not accidental. It's a little bit like the idea of a library, that we can make the robots available somehow at some site, and that citizens can come in and take them out. And we'll try to take advantage of all those volunteers that want to help in their environment, want to do these things, get the robots in their hands and allow them to collect the data. It's great through my inability to actually leave CMU. We've actually got a lot of CMU, sorry, I want to go this first. One of the interesting things is that a lot of the CMU scientists can't wait to get their hands on this data. This is still free data collected from them. So we've got professors there promising to take the data and turn it into journal publications if we can get it to that standard. And one of the nice things about using a robot is that we can control the quality of the data to some degree, or at least understand the quality of the data. CMU is now getting involved and are going to co-brand all this for us, provide curriculum, provide input to get all this done, which makes it sort of a combination of an outreach program. Everyone at Robotics Institute has a nice, easy, broader outreach section to write in their NSF proposals from now on. But it also helps us with curriculum development and all those sorts of things that we can put into these centers. And we can also, we're going to start with our robots because they're well designed for this, but we're encouraging anybody else that has robots that might be useful for data collection and might help this process to actually put them in the robot, in the Citizens Environment Science Center. And if you can come up with a better name, that's what we'd really appreciate. So what we're hoping this does is change the timeline of how some of this technology is getting into the hands of all these volunteers. At the moment, you know, your lab comes up with a prototype. It's sort of working. It's sort of collecting data. We've seen lots of good examples of them, but it takes another extended period of time before we can turn that into a product. And you know, having just gone through that, that's a lot of hard work and a lot of roadblocks there. And then you get it out to your big customers and your early adopters and deep-pocketed customers, and then, you know, some long distance down the track, you get it into the hands of you know, the thousands of volunteers that want to do good work with it. So what we really want to do with these libraries is actually put it in the hands of these guys first, to take some of these projects, to take some of the cool robots coming out of the Robotics Institute and other places, and send their prototypes out to these centers. Enthusiastic people, tech-savvy people, people willing to put up with the things that go wrong with a prototype and take it out and get them to do science in the world. So I put some crossed fingers on this here. We're in negotiation with a lot of these sites, but you know, at the moment it's looking like most of these negotiations are, you know, they won't all fall through, and we'll have an interesting network of centers up around the world over the next couple of years. And what's really important to us all is that there are going to be connections with these. The data is going to be shared, that the kids that are, you know, looking at rivers in you know, Mumbai can compare it with the kids that are doing it in Pittsburgh, with the kids that are doing it in Australia, and we can understand the different challenges that go on. And we're sort of arranging different educational activities and, you know, maybe a conference or something around that where people that participated can come together and share experiences. So with that, there's my contact detail. Rachel Burson's also here. She's the main CMU person that's pushing it from that side. Or you can go and have a look at the education part on our website to learn more. Thank you.
This is great. You were asking for ideas about scale this up and citizen science. So I don't know if you're aware, there's a non-profit called Bank USA. It actually started as Bank Atlanta, but now it's across the US. And they're
Toolbank, yes.
So they provide like tools like drills and all sorts of things for free to other charities, funds, organizations to help them schedule events like plant trees, build stuff. So as you were talking, it's really reminded me about like Bank, but for, you know, this kind of robots where people can like check out robots and then bring them back and kind of. Yeah,
we actually stole their license agreement as a thing. Yeah, oh, it's something like that.
So I think that's a great model.
Yeah, it is definitely an interesting model. I mean, there's some differences, and I think the differences in that. There's a sort of synergy between the data that different people collect, and we want to do some of the eBird sort of activities of spreading people out and getting them to do that, rather than just, you know, take the tool and do their thing and come back. But yeah, that sort of model, we have Tech Shop in Pittsburgh as well, which I know is a sort of fairly common model now, where some laser cutters and 3D printers and so on are available. So it's a little bit inspired by that model as well. Yeah. It's a good example.
Thank you.
Thank you.